Okay, so this is important that I is created and initialized on each iteration. Okay, so explain each of the following examples and correct any problems you detect. Okay, so this iterator uh, alright, iterator. Okay, um, this is wrong. This is wrong since the iter is being created on each iteration with default value and is never getting updated, and it is never getting updated, right? Okay, so then we have while bool status equals find word, it says if not status. Okay, status is declared, status can be what do you say, accessed within the uh, while loop only, and any reference any reference outside the loop uh, will result in error. Okay, so there we go. Alright, so conditional statements. C++ provides two statements that allow for conditional execution. The if statement determines the flow of control based on a condition. The switch statement evaluates an integral expression and chooses one of several execution paths based on the expression's value. Okay. So we have if statement. An if statement conditionally executes another statement based on whether a specified condition is true. Okay. So there are two forms of the if, one with an else branch and one without. Okay, so then in both versions condition must be enclosed in parentheses. Condition can be expression or an initialized variable declaration. The expression or variable must have a type. The expression or variable must have a type that is convertible to bool. Okay. As usual, either both statement and statement 2 can be a block. If condition is true, the statement is executed after statement completes. Execution continues with the statement following the if. If condition is false, statement is skipped in a simple if execution. In a simple if, execution continues with the statement following the if. In an if else, statement 2 is executed using an if else statement. To illustrate an if statement, we'll calculate a letter. Okay, so what are we doing? We are calculating. Okay, so it says, okay, so to illustrate an if statement, we'll calculate a letter grade from a numeric grade. We'll assume that the numeric grade ranges from 0 to 100 inclusive. uh, so a grade of 100 gets an A++, grade below 60 gets an F, and the other ranges in clumps of 10 grades from 60 to 69 inclusive get a D, 70 to 79 C, and so on. Alright, so we'll use a vector to hold the possible letter grades, right? Then we see to solve this problem we can use an if else statement to execute different actions for failing the passing grade. Okay, so if grade is less than 60, grade 0, else we say grade minus 50. Okay, else we have grade minus 50 divided by 10. Okay. Depending on the value of grade, we execute the statement after the if or the one after the else. In the else, we compute a subscript from grade by reducing the grade to account for the larger range of failing grades. 5. Okay. Then we use integer division, which truncates the remainder to calculate the appropriate score index. Okay. Nested if statement. To make our program more interesting, we'll add a plus or minus to passing grade. We'll give a plus to a grade ending in 8 or 9 and a minus to those ending in 0, 1, 2. Okay. So if grade mod 10 is greater than 7, it gets a plus. If grade mod 10 is less than 3, it gets a minus. Okay. Here we will use the modulus operator to get the remainder and decide based on the remainder whether to add plus or minus. We next will incorporate the code that adds the plus or minus to the code that fetches the letter grade from scores. If failing grade, no need to check for a plus or minus. Okay. As if letter grade, fetch the grade that adds a minus or plus. Okay, grade, if grade is not 100, then we have mod 10 a plus a minus letter grade. Okay. So then we have note that we use. Okay. Note that we use block to enclose the two statements that follow the first else. If grade is 60 or more, okay, so right. So we have two actions that we need to do: fetch the letter from grade store and conditionally set plus or minus. Right. So it was okay, a plus a minus. All right. It is a common mistake to forget the curly braces when multiple statements must be executed as a block. Okay. So then in the following example, contrary to indentation, the code to add a plus or minus happens unconditionally. Okay. So this in the following example, contrary to the indentation, the code to add a plus or minus happens unconditionally. Despite appearances without the curly braces, this code is always executed. Okay, right. Because there is no right. Despite appearances without the curly braces, this code is always executed. Failing grade will incorrectly get a minus or a plus. Okay. Uncovering this error may be very difficult because program looks correct. To avoid such problem, some coding styles recommend always using braces after if else and also around the bodies of while. Alright. Okay. So doing so avoids any possible confusion. It also means that braces are already in place if later modifications of the code required adding of statements. Okay. Many editors and development environments have a tool to automatically indent source code so that it matches structure. It is a good idea to use such tools if they are available. Well, okay. So then we have dangling else. When we nest an if inside another if, it is possible that there will be more if branches than else branches. Indeed, our grading program has 4 if and 2 elses. Okay. When we nest an if inside another if, it is possible that there will be more if branches than else branches. Indeed, our grading program has 4 if and 2 else. The question arises, how do we know to which if a given else belongs? This problem is usually referred to as dangling else. It is common to many programming languages that have both if and if else statements. Different languages solve this problem in different ways. In C++, the ambiguity is solved by specifying that each else is matched with the closest preceding unmatched if. Programmers, okay, then we have programmers sometimes get into trouble when they write code that contains more if than else branches. To illustrate the problem, we'll rewrite the innermost if else that adds a plus or minus using a different set of conditions. Okay, so wrong execution does not match indentation. The else goes with inner if. Okay, nope. This else goes with this. Okay. execution does not match indentation, the else goes with the inner if, right? Okay, the indentation of code indicates that we intend the else to go with the outer if. We intend for the else branch to be executed when the grade ends in a digit less than 3. However, despite our intentions, the contrary to the indentation, the else branch is part of the inner if. This code adds a negative to grades ending in 3 to 7 inclusive. Properly properly indented, properly indented to match the actual execution. What we wrote is this. Okay, properly indented, but still. Okay, so you should use, okay, controlling the execution path with braces. We can make the else part of the outer if by enclosing the inner if in a block. Okay. So statements do not span block boundaries. So the inner if ends at the close curly before the else. The else cannot be part of the inner if. Now the nearest unmatched if is the outer if, which is what we intended all along. All along. Okay, using an if else, write your own version of the program that generates the letter grade from a numeric grade. No, thank you. Okay. Rewrite your grading program to use conditional operator in place of if else statement. Okay. Correct the errors. Okay. So if both are unequal, else both are 0. Correct the errors in each of the following code. Okay, so it says if this value is not equal to this value, then we set it equal to this value, and if it is equal to this value, then we set both to 0. What is the error here? Okay, correct the errors in each of the following code fragment. um, okay, see this statement, right? Okay, there's a missing null statement. I think that is what you intended. Okay, then we have if. Okay, so this should be in a block. Int I equals get value. This is I will is part of if, so can't refer it outside 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 the if block. So you should do something like this. If I val, if not I val. Okay. Okay, then we have I val equals 0, then I val. Okay. Uh, the inner block will never execute. So check I val not equals to 0. Okay, then what is dangling else? How are else clauses resolved? Okay, so when there are more if statements compared to else statements, then which else is then it is a problem to identify which else is paired with which if statement. So to solve this, we pair it with the closest uh, closest unmatched if. Then we have the switch statement. The switch statement the switch statement provides a convenient way of selecting among a possibly large number of fixed alternatives. As one example, suppose that we want to count how often each of the five vowels in some segment of text. Our program, our program logic is as follows: read every character in the input, compare each character to the set of vowels. If the character matches one of the vowels, then add 1 to the vowels count and display the result. Okay, for example, when we run the program on the text of this chapter, the output is okay. So we can solve our problem most directly using a switch statement. Okay, right. A switch statement executes by evaluating the parenthesized expression ch. Okay. Parenthesized expression that follows the keyword switch. The expression may be an initialized variable declaration. The expression is converted to an integral type. The result of the expression is compared with the value associated with each case. Okay. If the expression matches the value of a case label, if the expression matches the value of a case label, execution execution begins with the first statement following the label. Execution continues normally from the statement through the end of the switch or until a break statement. We'll look at break statements in detail, but briefly, a break interrupts the current flow. Okay. In this case, the break transfers the control out of the switch. In this program, the switch is the only statement in the body of a while. Right, body of a while. Okay, breaking out of the switch returns control to the enclosing while. Because there are no other statements in that while, execution continues at the condition in the while. If no match is found, execution falls through. If no match is found, execution falls through to the first statement following the switch. As we already know in this example, exiting the switch returns control to the condition in the while. The case keyword the case keyword and its associated value together are known as case label. Case labels must be integral constant expressions. Okay. So this is error and this is error because it can't be a variable as well. Okay, it is an error for any two case labels to have the same value. There is also a special case label default which we'll cover next. Okay. Control flow within a switch. It is important to understand that execution flows across case labels. After a case label is matched, execution starts at the label and continues across all remaining cases or until program explicitly interrupts it. Okay, it is important to understand that execution flows across case labels. After a case label is matched, execution starts at the label and continues across all the remaining cases or until the program explicitly interrupts it. To avoid executing code for subsequent cases, we must explicitly tell the compiler to stop execution. Under most conditions, the last statement before the next case label is break. Okay. However, there are situations where the default switch behavior is exactly what is needed. Each case label can have a single value, can have only a single value, but sometimes we have two or more values that share a common set of actions. In such instances, we omit a break statement, allowing the program to fall through multiple case labels. Okay, so any occurrence. Okay, here we stacked several case labels together with no intervening break. The same code will be executed whenever ch is a vowel. Because because C++ programs are free form, case labels need not appear on a line. Okay, we can emphasize that the cases represent a range of values, listing them on a single line. Nice. Okay. Omitting a break at the end of a case happens rarely. If you do omit a break, include a comment explaining the logic. Okay. Forgetting a break is a common source of bugs. Okay. It is common miscon- it is a common miscon- it is a common misconception to think that only the statements associated with the matched case label are executed. For example, here is an incorrect implementation of our vowel counting switch statement. To understand what happens, assume that the value ch is e. Execution jumps to the code case e, which increments e count. Execution continues across case labels, incrementing I count, O count, U count as well. Okay. Although it is not necessary to include a break after the last label of a switch, the safest course is to provide one. That way, if an additional case is added later, the break is already in place. The default label. Statements following the default label are executed when no case label matches the value of the switch expression. For example, we might add a counter. We might add a counter to track down how many non-vowels we read. We'll increment this counter, which will name other count is the default in the default case. Okay, in this version, if ch is not a vowel, execution will start at the default label and will increment the other count. It can be useful to define a default label even if there is no work for the default case. Defining an empty default section indicates to subsequent readers that the case was not considered. A label may not stand alone. It must precede a statement or another case label. If a switch ends with a default case that has no work to do, the default label must be followed by a null statement or an empty block. Okay. So variable definitions inside the body of a switch. As we've seen, execution in a switch can jump across case labels. Okay, as we've seen, execution in a switch can jump across labels. When execution jumps to a particular case, any code that occurred inside the switch before that label is ignored. The fact that code is bypassed raises an interesting question. What happens if the code that is skipped includes a variable definition? Okay. The answer is that it is illegal to jump from a place where a variable with an initializer is out of scope to a place where the variable is in scope. Okay. So error. Control bypasses an implicitly initialized variable. Okay. Control bypasses. Okay. So here it's not initialized. Okay. So then we have okay, jval is not initialized. Then we have case 2. Okay. Okay, jval is in scope but uninitialized. Alright. So okay, assign a value to jval. File name is in scope but wasn't initialized. Okay. If this code were legal, then anytime control jumped to false case, it would bypass the initialization of file name and ival. Those variables would be in scope. Code following false could use those variables. However, these variables would not have been initialized, As a result, the language does not allow us to jump over an initialization if the initialized variable is in scope at the point to which the control transfer. Okay. If this code were legal, then any time control jumped to false case, it would bypass the initialization of right. Okay, so it would not initialize these. Okay. Okay. Then code following false could use those variables, right? However, these variables would not have been initialized. Okay. As a result, the language does not allow us to jump over an initialization if the initialized variable is in scope at the point to which control transfers. Okay, we can define it in a block. If we need to define and initialize a variable for a particular case, we can do so. We can do so by defining a variable inside a block, thereby ensuring that the variable is out of scope at the point of any subsequent label. Okay, so we have write a program that uses a series of if statements to count the number of vowels in vowels read from Cn. There is one problem with our vowel counting program as we've implemented it. It doesn't count capital letters as vowels. Write a program that counts both lower and uppercase letters as the appropriate vowel. That is, your program should count both A and A as part of A count and so forth. Okay. Modify your vowel counting program so that it also counts the number of blank spaces, tabs, and new lines. Okay. Modify our vowel counting program so that it counts the number of occurrences of two character sequences F, F, L. Each of the program in the highlighted text on 184 page contains a common programming error. 184 highlighted. Oh, okay. Correct. Okay. So I can do this. I can do this. Okay, let's do it the right way. Let's do the exercise. Okay. 5.3.2. Okay. So this is section 5.3.2, and then this is exercise 5.9. Okay, so we need write a program. Okay, so I'll create say input string. Let me create a string s equals to this. Okay, then we'll loop for char ch and s for char ch and f. Okay, so I have to use series of if statements. Okay, so we can go if ch equals a This is a count, right? Count the number of vowels in text. Okay, so I want to read the number of vowels. Okay. Ah. Or ch or ch equals e a e a e I o u a e I o u. And I want to say let's declare int vowel count equals 0, and we will increment vowel count and write number of vowel counts in s string number of vowels in string r. This is vowel count and l, right? That is it. Write a program. Text read in from cn. No, sorry, thank you, I'm not writing cn. Okay, so alright. So it says missing terminating character. What are you talking about? Okay, this. You meant this, right? Okay, 31. Okay, I don't have time to, but I'll assume that that's okay. There's a problem with our vowel counting program. As we've implemented it, it doesn't count capital letters as vowels. Okay, I count. So I would have so this is 5.10 CPP string and string. So main string is equals to, I'm going to copy can I have there is one program. Okay, I just alright. Then we have int a count equals to e count equals to but yeah, I cannot declare and define at the same. I can say 0 a count equals 0, then ae I count equals 0. U. Okay, so now I cache ch and s. We can say we can put a switch on ch, and then we find case case A and a case A, then we can increment A count, right, and then we can break. Okay, A, E, E, I, 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 O, 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 U, we have U, and then we have U. Okay. Um, instead of case A, okay, case A, case A, break. We can directly write them in a single line. Okay. Then we can print same things. Number of A. Okay. Okay, 2, 3, 4, 5. Alright, so give me here and here. Ay. Okay, no. Yeah, okay. I did that right. Okay. A, E, I, O, U. Okay. Difficult. Then we can go C++, write that in CPP. Alright, great. Okay, so this is done. Okay. Modify a val counting program so that it also counts the number of blank spaces, tabs, and new lines. Okay, so I can just copy. Is there a way to duplicate? No, right? I cannot duplicate a tab. Diff with current tab. Diff. And how do I close this? Select all, cut, navigate to definition. Okay, so split view. how do I close this, bro? Yeah, okay, thank you. Just a minute. Okay, so modify so that it also counts number of blank spaces, tabs, and new lines for it. Okay, so I'll add a new line here. I'll add a tab here. Okay, so now just same program. .1.cpp, right, 5.11, and I just have to add this, say new line count, and then space count, and then tab count. Okay. Okay, we have a new line, so plus plus. Okay, so we have a tab and then a simple space. So space. Then number of new line and R and L count. Okay. Okay, so we have space, tabs, new lines, space, and tab. So I can go. Ah, sorry. Okay. New lines 1, spaces 17, tabs 2. Huh. I only included single tab. Ah, I think this is tab. Okay. Okay, and if I remove this right here, yep. Okay. So this is done too. Okay. Modify a while counting program so that it counts the number of occurrences of the following two character sequences. How can we count two characters? Okay. Okay, so F. Okay. Put another F. Yep. .cpp. So I would have to say auto begin equals to s dot begin, and then I'd say we going to write okay, it should, I think it will be better, equals 0, and then I less than s dot size. I suppose size is a function, and I less than size minus 1, and I plus plus. Okay, so we can put so s of I, right? I can put it on s of I, and then I can check case f, right? So I'll add a break so I don't forget it. Then we put switch on off I plus 1. Then we go case f break, case L break, and then we have a case I. Break. Okay. So occurrences so that it counts the number of. Okay, so alright. Iterator. Okay. So this can go, and yeah, that is all. Okay, so I can go with ff count, fl count, and fi count. ff, fl, fi, ff, fl, fi. Okay. Yeah. Then I can increment ff count here, fl count here, and fi count here, right? Modify our while counting program so that it counts the number of occurrences of the following 2 character sequences. ff, I don't think there are, but I'll put some. Okay, so ff, mpeg, flourish, and fish. It should be 111. Okay, so we have G++. This is 5.12. Yup. Okay, great. I think I should use the iterators. Start begin. Begin is a lesson. Let's start end. Yep, -1, and I can go iterating through iterator, string iterator. We'll see. If not, begin +1, and then begin ++. Let's try this. If this works. Yep. Okay. Iterates through each of the. Yeah. Okay. Good. Okay, then Each of the programs in the highlighted text on page 184 contains a common programming error. Identify and correct each error. Okay, let's count switch a default so right with break then break. So some value outside index 1 IVAC right can't what is this? Can't initialize. Can't initialize, only declare. Can't initialize, only declare. So you should go with int ix. Okay, so this will fix it because ix will get the value. Right. So unsigned even count, odd count, int digit equals get num mod 10. Yeah. Can't separate. Okay, can't separate cases by comma. So you will have to do case 1, case 3, case 5, case 7 and case 9. Then you have to do case 2, case 4, case 6 and case 8 and case 10. Okay. Okay, I will break. Okay, right. Can't have variables in cases need a constant expression. So let's get rid of this. What is this IVA? Answara. उसकी जगह आएगा 0 2 in place 1024. Okay, bring it in or close. Okay, then kval 4096. Alright, so that is it. Okay, so then I'll move on to iterator statements.